Let's consider another example. 3 to the second power divided by 3 to the fifth power. Using our standard order of operations, doing the exponents first, we'll get 3 times 3 over 3 times 3 times 3 times 3 times 3. And then what happens is we could either multiply that out and get 9 over 243, or there's an easier way to do this, because once we do that, we're going to have to reduce. We have to factor out a 9, so to speak. And we end up with 1 over 27. We can see that a little bit easier if we go ahead and do our reducing first. I can reduce this 3 with this 3 and this 3 with this 3. Again, even though I've canceled out both of these 3's, because the starting point of multiplication is a 1, that means the numerator is a 1. And so I have 1 over 3 times 3 times 3, which ends up being 1 over 27. Okay. Another way to think of this is the same as 1 over 3 to the third power, isn't it? There are 3 3's that end up in the denominator there. Now, why do I go into all this? Because we have a fraction here, and so we can apply the quotient rule. The quotient rule tells us that this should be equal to 3 raised to the power 2 minus 5. And of course, 2 minus 5 is going to give us negative 3. Whoops. So everything that I've written on here is equal. All of these are different ways of writing the same thing. In particular, what I want to focus on is this. 3 to the negative 3 power is the same as 1 over 3 to the third power. This gives us a clue about how to deal with negative exponents. If we have a negative exponent, that means that instead of having 3 copies of 3 that we're multiplying together, this negative exponent tells us we're going to do the opposite of multiplying, which is to divide. We start with our starting point of 1, and we divide by 3 copies of 3. We see that right here. That's the same as 1 over 3 to the third power. And so the negative exponent, in a sense, tells us to do the opposite. You can think of it as dropping the number down to the denominator. Anytime we have a negative exponent, we can handle it in this way. The negative exponent rule. For any real number a and any integer m, a raised to the negative m power is equal to 1 over a to the positive m power. Of course, a must be non-zero so that we do not have zero denominator. Here are a couple more examples involving negative exponents. If I have 2 raised to the negative 5 power, that negative exponent tells me bring that thing down to the denominator. So it's 1 over 2 to the positive 5th power. In other words, 2 to the 5th power tells me 5 copies of 2 multiplied together. Negative 5th power means 5 copies of 2 that I'm dividing by. So 1 over 2 to the 5th, and 2 to the 5th is 32, so I get 1 over 32. Second example, 2y to the negative 3 power. Again, that negative 3 power tells me I bring that down and make it a positive 3 power. But again, we have to be careful about our base. See, this negative 3 only applies to the y. So the 2 gets left in the numerator, while the y to the third goes to the denominator. Here's another kind of different example. What happens if I have a negative exponent in the denominator? Well, let's think about it. 1 over 5 to the negative fourth. That fraction really means 1 divided by 5 to the negative fourth. Now, it's not really in a denominator anymore, so I'll just do what I've always done. 5 to the negative fourth is equal to 1 over 5 to the positive fourth. So 1 divided by this fraction, if we remember how to divide by fractions, we can do it by multiplying by the reciprocal. So this is 1 times 5 to the fourth over 1. Of course, you do that out, you get 5 to the fourth power, and 5 to the fourth power you can write as 625 when you evaluate it. The point that I want to make here is that these two expressions are equal to each other. So if a negative exponent tells us to drop down to the denominator to make a positive exponent, a negative exponent already in the denominator tells us bring it up to the numerator and make it a positive exponent. So this is sort of like a special case of the negative exponent rule. Here's one more special example. If I have a fraction raised to the negative power, what does that mean? Well, through a long explanation, I can arrive at what it means. First of all, the negative 1 power means drop it down to the denominator. Then, of course, like in the previous example, I'm dividing by a fraction, so I can multiply by the reciprocal, and 1 times 3 halves is just 3 halves. So what I've done here is raising this fraction to a negative power simply means taking the reciprocal, because I've taken my numerator and moved it down to the denominator. I've taken my denominator and moved it up to the numerator. Here's a summary of the rules that we've seen so far. Remember that anywhere we have a denominator, such as in the negative exponent rule or in the quotient rule, that denominator cannot be equal to 0. Here's an example where we use several of the properties together. P squared q to the fifth, p to the negative second, over q to the negative sixth. There are a variety of ways we can approach this. One possibility is use the product rule to get our p's together. P to the second times p to the negative second. 2 plus negative 2 is going to give us an exponent of 0. At that point, since we have an exponent of 0, we can use the 0 exponent rule to say that p to the 0 is simply 1, and so we've gotten rid of p altogether. To finish this up by getting our q's together, one possibility is to use the negative exponent rule to bring this q to the negative sixth up to the numerator as q to the positive sixth. So we'll end up with q to the fifth times q to the sixth. Then again, we apply the product rule. 5 plus 6 gives us 11 in the exponent. Another possibility would be from here to use the quotient rule. The quotient rule says when I have a quotient, I can simply subtract the exponents. So my exponent is going to be 5 minus a negative 6, or 5 plus 6, 11. So by the quotient rule, I would get q to the 11th as well.